Alright, so in this video we are going to learn how to multiply and divide rational expressions. In pre-calc we're in A5 part 2. This is following the video on simplifying rational expressions. So if you haven't seen simplifying rational expressions yet, go ahead and watch that first. So let's go ahead and get started. So before we actually work with rational expressions, I would like to just remind you how to multiply fractions together. So multiplying and dividing rational numbers, right? Fractions are ratios. So let's take and multiply 2/3 times 5/4. Okay? When I want to multiply two fractions together, what I'm doing is I'm multiplying the numerator times the numerator, so 2 times 5, which is 10. And then I'm multiplying the denominator times the denominator, so 3 times 4 is 12. So my result here is 10/12. Now 10/12 can be reduced, right? Because 10 is 2 times 5, as we just saw. But 12 can also be written as 2 times 6 or 2 times 3 times 2, right? If I multiply 2 times 3, I get 6, and 6 times 2 is 12. The reason I'm writing it like this is because everything here is a prime number. So remember, prime numbers are numbers that can only be divided by 1 in itself. Like 5 is prime because 1 times 5 is the only way to multiply to 5. But 6 is not prime because for 6 I can either do 1 times 6 or 2 times 3. So it's prime once you can't divide it down any further except for using 1 in itself. So I'm writing it like this because now I can see what needs to cross out or cancel out. 2 divided by 2 is 1, so that part just becomes a 1. And then I'm left with 5 over 6. Now most of you could probably just look at 10 over 12 and know that it reduces down to 5 over 6 without writing it all out like this. But I want you to kind of think about that process and why it works. Why do we reduce it to 5/6? Because that's going to become important when we work with our rational expressions. All right, so let's try another one. So 1/3 times, let's say, 12 over 7. Okay. So again, I'm going to multiply the numerator times the numerator to get 12, and I'm going to multiply the denominator times the denominator to get 21. Now, in order to reduce and simplify my fraction, I'm going to write it out. So 12 is 3 times 4. 3 is prime, so I'll write 3 here. 4 is 2 times 2, so I'm going to write it as 3 times 2 times 2. And 21 is 3 times 7. Those are both prime. So just so I can see all of the factors in the numerator and the denominator, so I can see which ones are going to cancel out, which in this case is just the 3 over 3. And then I'm left with 4/7. Okay. Now when you divide two fractions, so if I do 2/3 divided by 5/4 instead of times 5/4, what ends up happening is that when I divide a fraction, it's actually the same as multiplying by the reciprocal. So the first fraction is going to stay the same. The second one, the 5/4, that one is going to get flipped over. I'm going to use its reciprocal, okay? And then I'm going to change my divide to a times, because dividing by a fraction is the same as multiplying by its reciprocal. So on the top I have 2 times 4, which is 8. On the bottom I have 3 times 5, which is 15. So now I can reduce this by writing it out as prime factors. So 8 is 2 times 4. And 2 is prime, but 4 can be broken down to 2 times 2. So 8 is 2 times 2 times 2. 15 is 1 times 15, 3 times 5. There we go. 3 times 5. 3 times 5, they're both prime, and that equals 15. So I see there's no common factors here, and so 8 over 15 can't be reduced anymore. Okay, so we're going to use, some of that as we go forward. So have that in the back of your mind. All right, here we go. Here's our first example. Let's see if I clicked one. Oh, okay. So here are the steps for multiplying rational expressions. Okay, if you want to write this down in your notes, go ahead and pause the video and write these down. So the first thing we're going to do is factor everything. So when we were working with the fractions on the previous page, we factored everything so that we could see each prime number that made up the top number and then each prime number that made up the bottom number. Then we're going to combine the numerators and combine the denominators. So we actually did that first last time. If we had 3 times 5, we multiplied them together to get 15. So when it says combine the numerators and denominators, we're just putting what is multiplied together on the top, what is multiplied together on the bottom, and we only need one division sign, right? Then we're going to see what will cancel out. What becomes a 1? If I have the same number or the same variable on the top and the bottom, they're going to cancel out and become a 1. Lastly, I'm going to check for extraneous solutions. So when we're working with rational expressions, we know we can't divide by 0. And because we can't divide by 0, we have to make sure that any x value that's on the bottom, so let's say I have 2x plus 5 over 7x. When I plug x's in, I need to make sure I don't get a 0 on the bottom because dividing by 0 is undefined. So to find that, as we learned in the last video, I take 7x and set it equal to 0. Well, that is not working well. I would have to take the denominator, which was 7x, and set it equal to 0 and solve for x. And in this case, I would just divide both sides by 7. Since x divided by 7 is 0, in this one, x cannot be 0, right? So you got to be thinking about what values will make my denominator equal 0 because I need to exclude those values. Okay? So let's go ahead and try an example. So I have 2x over 5 times 15 over 3x. Now, I know that when I multiply these together, I'm going to be multiplying the numerator times the numerator, the denominator times the denominator. But remember, I don't want to write them as, I don't want to write 2x times 15 as 30. I want to write it as all the factors that I can written out so I can see which ones match in the numerator and the denominator. So I have a 2 times x times 3 times 5. The 3 times 5 came from 15, right, in the numerator. And then I have 5 times 3x on the bottom. So now I can see that there is a 5 that will cancel because 5 divided by 5 is 1, a 3 over 3, and an x over x. So this actually just reduces down to a 2. Okay. Now I have to think about what can x not be. So I need to look at the denominators, both of them, 5 and 3x. The 5 has no variable with it, so I don't have to worry about that one. There's no way that 5 is magically going to change into a 0 without a variable. Alright, so sorry, we had a technical difficulty there. So we got that this equals 2, right? And then we were checking for extraneous solutions. So the 5 we decided doesn't matter because it doesn't have a variable. The 3x does have a variable of x. So I'm going to take 3x and I'm going to set it equal to 0. And then I need to solve that equation for x to find out what x cannot be. So just divide both sides by 3. And my marker is just not working. But so x does not equal 0. Right? X can be anything else, but once I put a 0 in for x, that's going to give me that 0 on the denominator, and 15 divided by 0 would be undefined. So that is why x cannot be 0. Alright, so let's try another example. So here we go, 5x squared over 2x times 12 over x. So let's go ahead and break it down. Remember, everything is going to be combined on the top, the 5x squared times 12. I'm going to break everything down so that it's an individual factor. So x squared is x times x. So this is going to be 5 times x, and then 12 would be 3 times 4, right? And the 4 would be 2 times 2. So I want everything to be factored down until it is a prime. And then on the bottom, I'm going to multiply the 2 times the x times the x. So if I do it this way, and now I have each factor written out individually, I can easily see which ones can cancel out, right? Which ones have the same factor on the numerator and the denominator, because any of those will just become 1s. And then I can just see what's left over. So on the top, I have still 5 times 3 times 2. So 5 times 3 is 15, and 15 times 2 is 30. On the bottom, everything canceled out. So the only thing that would be left down there is a 1. But of course, if the answer is 30 over 1, I don't need to write the over 1 part, right? It's just 30. Now remember, every time you do one of these problems, you also need to think about what the denominator cannot be. And in this case, we have two denominators, and I'm going to look at both of them. I have a 2x, and I have an x. Now, if I set each of these equal to 0 in order to find out what x value makes them true, in both cases I get x equals 0, right? Because 0 divided by 2 is 0. And so I don't need to write the answer twice. I can just write my simplified version of the rational expression. And even if all of the x's cancel out, I still need to write what x cannot equal. So x cannot be 0. Okay? So even though it happened twice for each denominator, I only need to write it one time. All right, so this one looks a little more complicated, right? So I've got x plus 2 over 12x times 6 over x plus 2 times x minus 1. Now when you're simplifying rational expressions and when you're multiplying and dividing rational expressions, you really need to be careful about trying to cancel things out that can't be canceled out. So for example, and I'm just going to kind of ignore this problem for a moment, and I'm going to ask you a question. So if I have x plus 2 divided by x, if I'm trying to simplify this, is it okay to cross out the x and the x like that? Okay? And the answer is it's not, because let's just think about what that would mean if x is a value. So let's say that x is 5. So if x were 5, then x plus 2 over x would be 5 plus 2 over 5, right? Now 5 plus 2 over 5, that equals 7/5. Now if I were to cross out the 5's with that plus in the middle, that would give me that this reduces to a positive 2, right? And the 5's went away. So 2 does not equal 7/5, okay? Because the plus or minus is between the two values, it's between x and 2, that is what makes it so we can't cross out just part of it, because it's a plus or a minus, it's not times. It's not a factor that's getting crossed out, it's a part of a number that's being added or subtracted. So you have to be really careful when you're looking at these, not to cross out things that are part of a plus or minus. So for example, if I'm just looking at the first part of my expression, x plus 2 over 12x, it's tempting to think that I can cross this out, x out, and this one, because this one's on the top and this one's on the bottom. But because this x is it's grouped together with the plus 2, and it's part of that number, I can't cross that out. In order to cancel anything out when there's pluses or minuses between two of my values, I have to have the exact same thing on the top and the bottom. So I know that when I go ahead and multiply everything together here, I'll need to put parentheses around x plus 2, and then I'm going to multiply that by 6, but remember I want to break everything down as much as I can. So x plus 2 times 3 is on the top. So the three factors that are in the numerator are x plus 2, 2, and 3. So in order to cancel out any of these, I'm going to have the same on the bottom, but with no pluses or minuses between them. I don't know if that makes sense. Well, let's try it. So 12, as we know, is 3 times 4, and 4 is 2 times 2. So I've got 3 times 2 times 2 times x, and then I've got these other two factors, x plus 2 and x minus 1. Now, while it's true that I can't cancel out part of a plus or minus expression, like I can't cross out this 2 right here and this 2 right here, because this one is part of a plus, I can cross out x plus 2 over x plus 2, because no matter what x is, that's going to be the same number, right? If I put 5 in here, that's going to be 7 over 7, and 7 over 7 will cancel out, since everything here is multiplied. So x plus 2 and x plus 2 cancel. One of these 2's will cancel with one of these, and the 3 will cancel with one of these 3's. So what do we have left on the top? Everything canceled on the top with something on the bottom, which means the only thing left up there is a 1. On the bottom, I still have 2 and x minus 1. So there's the simplified version of our expression. Now, I need to find out what my extraneous solutions are, which is called, or my values that x can't be, right? I can't look at my simplified fraction to do that, or my simplified expression. I need to go back up here before anything was canceled out. In fact, I don't have to go all the way back up to here, but I would need to look at the bottom along here to see which factors would make it go to 0 if x were certain things. And I'm thinking it's probably easiest to look here because we have a whole lineup of all the possible factors in the denominator. So let's go ahead and look at them. So I have an x right here. Now if I plugged in a 0 for that x, that's going to make the whole denominator go to 0, right? Because 0 times anything else, no matter what all this other stuff is, will be 0. So I know x can't be 0 because of that one. For x plus 2, what will make that one equal 0? So if I have x plus 2 equals 0, that means that x cannot be negative 2, right? Because if it were negative 2, when I plug negative 2 down here, I'm going to get negative 2 plus 2, and that's going to make this one go to 0, and then I'm going to have 0 times all these other numbers. And then for the last one, for x minus 1 equals 0, I would just add 1 to each side. So x equals 1, which makes sense, right? Because 1 minus 1 is 0. So these are the 3 values that x cannot be. So in this case, there are 3 different ones it can't be. Okay, so just make sure you do that little step at the end. Here's the simplified rational expression. Here are the values that x cannot be, because that will make it undefined. Okay, on this one, I'm going to do the same thing. I'm going to take everything across the top and I'm going to write them side by side. I want to have everything written as a single factor, so anything that's squared I'm going to write out. Any number that has more than one factor, or I mean that's not prime, will be written out. On the bottom, I have to group this x plus 5 together. So I'm going to have x, and then I'm going to have to put parentheses around x plus 5. Now x plus 5 and x plus 5 match, so I can cancel those out. X up here and x down here matches. The only thing I have left is 2x. So the numerator went away. The only thing I would have left down there is a 1, and I don't need to write 2x divided by 1. That's the same as 2x. And then I need to look at my denominator and see which factors will make the denominator equal 0. So since there's an x down here, I know x cannot be 0 because that would make, if I plug 0 in right there, that would make the whole thing go to 0. Likewise, x cannot be negative 5 because negative 5 plus 5 is 0. And so those will be my 2 excluded values for this one. Okay, let's try another one. Okay, so now this one is looking a little bit different. That's because the others that we've done have already been in factored form, and this one isn't in factored form. So we need to get it into factored form. So before we begin, we're going to look at each numerator and each denominator separately. And we're not going to try to simplify anything across the equal sign. We're only going to see if there's anything that can be factored in the numerator and the denominator. So in the numerator here, 6 I can write as 2 times 3, right? Let's start over since my marker's being weird. So 2 times 3 is this first numerator. This is the, numerator. The second thing we're going to look at is the denominator for the same thing. So we have 4 times n, which I can write as 2 times 2 times n. So we're just factoring everything so we can see every factor that's available there. Then we're going to move to this one. So 4n squared minus 40. I can see that there's a common factor of 4 and also of n. So we just go ahead and factor out the 4n, and that will leave n minus 10 inside the parentheses. Quickly double check and make sure if you were to multiply it back through, you get the same thing back. And then I have the n minus 10 down here. So now that everything's factored, I'm going to combine everything in the numerator, oops, I forgot to factor 4 as 2 times 2. Alright, let's erase this and keep going. So everything in the numerator will be combined over the numerator. Everything in the denominator will be combined in the denominator, and then we'll look for things that can cancel. So 2 times 3, that's this 2, this 3, and we have times 2 times 2, and then times n minus 10. On the bottom we have 2 times n, and then we have this n minus 10. Remember, that's grouped together because of this symbol right here. So we're also going to put parentheses around that. So now I see that the n minus 10 can cancel, 2 of the 2's can cancel, and that's it. So on top we have 2 times 3 left, which is 6, and on the bottom we have an n. So that is the simplified expression. Now we want to go back up to our factor form here and check out what n cannot be. So because of this n cannot be 0. And because of this factor, n minus 10, n cannot be positive 10. Because if n is positive 10, 10 minus 10 will make 0 in the denominator. Okay? So remember, your solution should have 2 parts, the simplified expression and the values that n cannot be. Alright, so on this one, it looks like I need to factor. Remember, this quadratic can be put in factored form by using x factoring. So let's go ahead and do that. So a is 1, b is negative 3, and c is negative 40. So remember, in the top I need a times c, or 1 times negative 40, which is negative 40. On the bottom I have b, and b is negative 3. So I'm looking for 2 numbers that multiply to negative 40 and add to negative 3. So I could do 1 and 40. Remember, if this is a negative number, it means one of these numbers is going to have to be positive and one's going to have to be negative. But either way, 40 plus 1 and 40 minus 1, I'm not going to be getting 3 from that. I could try 2 times 20, but again, that won't give me 3. 3 doesn't go evenly into 40. 4 and 10, which does not give me 3. 5 and 8, there we go. 5 and 8 has a difference of 3. My difference is a negative number, which means I know the bigger number here is going to need to be negative. So my 2 factors are negative 8 and 5. I always want to divide my factors by a, but a is 1 in this case, so it's not going to change anything. So this top part is going to factor to x minus 8 times x plus 3. Nope, 5, not 3. Okay, and then I'm going to multiply that by this 5. And all of that is going to go over 3 times x times, and remember, x minus 8 is grouped together, so when I write it next to 3 times x, I'm going to have to put parentheses around it. And then just look for all of the matching factors, which in this case is just x minus 8. X plus 5 times 5 is going to have to stay like that, and 3x. So there's nothing else that will cancel here, so that's my simplified expression. I could multiply the 5 through and write it as 5x plus 25. That would be fine too, but I'm going to leave mine like this. And now I just need to think about my denominator before anything got canceled out and look at the values that x cannot be. So because of this one, I know x cannot be 0. And because of this one, I know x cannot be 8. 8. Okay. I think we have one last example. On this one, 2n minus 6, I can't x factor it or anything. There's not another n here, so I can't pull out that type of factor, but I can pull out a 2, and that would leave me with, let's try that again. I can pull out a 2, and that would leave me with n minus 3, and then just times 1 on the top, so I don't need to write that down. And on the bottom, that n minus 3 is grouped together, so I'll put parentheses around it, and then times 6n, and 6 is 2 times 3, and then times n. So the n minus 3 cancels, the 2 cancels, everything left canceled from the top, which just leaves a 1 up there, and then 3n on the bottom. So there's the simplified rational expression, and now I need to think about what n cannot be. So looking at my denominator, I had an n minus 3, which means n cannot be positive 3, and I had an n, which means n cannot be 0. Alright guys, good luck with the homework on this section, and let me know if you have any questions or problems.